Hello everyone, and welcome to another Unboxing Tomorrow Technology Watchlist as we launch into 2021 and a brand new year of electronics, robotics, and communication systems. With those areas in focus, here are 10 areas that I think are going to have substantial growth over the next decade. First off, last year's list is still in play. Everything from its predictions on artificial intelligence and landmine detection, and even a lot of the fundamentals like analog-digital conversion. I won't be repeating those items, however, you can find a link to last year's list in the description. I'd like to thank our affiliate TorGuard VPN. VPNs, or virtual private networks, can help protect your personal information, but more on that later. For now, you can find details in the description. Number 1 is IoT Security Extensions. The recent viral outbreak disrupted a lot of projects and plans that the industry had set just about a year ago. But cybercrime gave us no reprieve, with even the US Department of Justice issuing multiple advisories throughout the year about escalating cyber attacks and malware. But even if this hadn't been the case and 2020 had proceeded normally, we still would have seen record attacks against IoT infrastructure, with security firms like F-Secure estimating these attacks to be in the billions. IoT, or Internet of Things devices, have historically been easy prey for hackers because of their high specialization and low computing power. They are simply soft targets compared to personal computers and servers. Luckily, advancements in semiconductor manufacturing and higher device densities are giving us new microcontrollers that now have more cryptographic resources built in. Resources for things like random number generation, one-time programmable memory, encryption, hashing, and so on. And as long as consumers are reasonably security aware, these devices are bound to become more popular. Hey everybody. So after recording the audio for this, I circled back and start reading a couple of white papers from the NIST, and without going into great detail for now, I'm going to have to add quantum-resistant cryptography to the list. For anyone unfamiliar, where the current generation of computers process data in terms of ones and zeros that are discrete and well-defined, quantum computers process information more as a superposition of many possible states. And because of this, they can be used for levels of code breaking that would be completely intractable for even a large bank of powerful current generation computers. Long story short, internet security, banking security, many cryptocurrencies and blockchains are really under what you might call a quantum threat. Even though I don't really expect to see too much growth in the year 2021, I would wager that by 2022 or maybe the following year, quantum resistance and post-quantum cryptography is going to become more of a burning issue, even for us hardware developers. Number 2. UVGI disinfection. Ultraviolet germicidal irradiation will use ultraviolet light to destroy viruses and bacteria. Since the early 20th century, this involved mercury vapor and its UV emissions. Its emissions near 253.7 nanometers is germicidal, and a second line at 185 nanometers generates ozone. We've already seen a surge in this technology, and we're even seeing a new family of LED that can potentially replace these sources. Mercury is a toxic material, and regulators are already committed to keeping it out of the waste stream and out of air freight. The LED-based solution also avoids the problem of generating ozone, a common indoor pollutant. Regardless of whether the UV comes from a mercury source or an LED source, this could also spur a surge in UV detection and dosimetry, but because of the natural hazards of UV radiation itself, the growth will likely be concentrated in areas that are best suited to deal with it most effectively, namely healthcare. Number 3. Unmanned aircraft. Unmanned aerial vehicles, UAVs or drones, have become a very multidisciplinary field because of their growing roster of civil, commercial, and military uses. Speaking strictly about the civil and commercial applications, I suspect the initial growth in the start of the decade is going to happen most in agriculture, which has been surprisingly ahead of the curve when it comes to vehicle automation. These drones can evaluate crops in a number of ways, and we are seeing that food security has become more than just a talking point for investors, since anything that can increase crop yields is going to be a strong value proposition. We've also seen very recently, just a few days ago in fact, that the US Federal Aviation Administration has released their remote ID mandate for aerial drones, so they are clearly anticipating more growth. Number 4. Serializers and deserializers, or SERDES for short. When two digital systems need to communicate at high speed, they usually do so over cable. The lightest and cheapest cables available will always use the fewest conductor pairs that they can manage, which can be as low as a single one. This coaxial cable is a common example, and it's just a type of interface that a SERDES excels at using. For example, if you had a vehicle with a rearview camera, just one cable like this can deliver data and power to a digital display elsewhere in the vehicle. The serializer starts this process using a parallel bit pattern, which will transmit down the cable one bit at a time. This is the serial data, and so far the serializer behaves like its predecessor, the shift register. At the opposite end, the deserializer reverses the process and reconstructs the data at high speed. Many SERDES part numbers can embed a synchronizing clock signal in these high-speed data streams, so when these cables are filtered, one simple cable can serve the data, the clock, and electric power over very low-cost cabling. So it's no surprise that we're already seeing SERDES chips used in physical layer standards like Gigabit Ethernet and others, and when the cable uses fiber optics, they can even use the fifth item, silicon photonics. Large-scale data centers were already trending before the viral outbreak, and this only accelerated after enterprises pivoted to telework, online commerce, and VPNs out of necessity. TorGuard VPN is the VPN service that I use, and when you use the affiliate link in the description below, you can sign up to start protecting your online data. Use the following promo code for discounts on the streaming bundle, because it's reliable, easy to use, and fast. Today, the field of silicon photonics delivers high-speed data by merging silicon-integrated circuits and semiconductor laser technology. This combination can be implemented using the SERDES devices we already saw, resulting in fast data transfers over long distance. Silicon photonics data rates are pushing terabits per second, so I think it's fair to say that this field is going to do what fiber optics did back when they replaced copper phone lines many decades ago. Number 6. Microfluidics. This is a life science technology that's been around for a while, mature and widely trusted, but more to the point, the future of outbreak response will probably drive this field even further. Like the name suggests, these are microstructures and electrical instruments that can capture fluid samples from a patient. The sample can be as small as a few nanoliters, and once it's captured, the instrument can use immunoassay techniques to search for telltale signs of an infection or a pathogen or biomarkers from the patient. These so-called lab-on-a-chip implementations are getting better with every generation, and we know medical testing is a huge priority right now. Number 7. Electric vehicle charging. This was a record-setting year, not just for electric vehicles, but for electric vehicle infrastructure, which I think is significant considering what the oil futures market did back in April and May. Digital payment systems for public EV charging stations will probably benefit from the secure microcontrollers I covered earlier, but more importantly, these electric vehicle charging networks are really hoping to expand their reach beyond urban centers and into the vast areas that are sparsely populated, not to mention retail areas and suburbs. It's also a growing R&D field. Many people take it for granted, but gasoline is remarkably energy dense, around 46 megajoules per kilogram. A single 50-liter fuel tank represents a 2.3 gigajoule chemical energy payload, and even though an engine will only harness a small amount of that energy, that's a lot of energy being transferred from the supplier to the consumer in just a matter of seconds. To compete with this, charging station developers have to face the already high expectations of future car buyers who are already used to getting this rapid refueling experience just about anywhere they go. So this has fueled what you might call an investment frenzy into powerful charging infrastructure. We're talking 100 kilowatts and beyond. So far, I think it's just getting started. Number 8. Gallium nitride and silicon carbide are two semiconductors that are seriously beginning to challenge silicon in fields like power electronics, wireless charging, and wireless communications. These aren't new materials, but for many years, they were relegated to very specialized, very niche uses like satellite communications and tactical radar for the military. Because of new fabrication techniques and increasing yields, we are starting to see them both take on more mainstream applications, and in spite of their current cost disadvantage and higher defect rates, they outperform conventional silicon in very substantial performance areas. Namely, they have a wide band gap, they have excellent dielectric strength, which makes them more durable, and higher electron mobility for higher speeds. 5G communications did make the list last year, so I expect this to be the main driving factor in the upcoming growth. Number 9. Asymmetric computing. Multi-core processors have been a staple in personal computers for quite a while now. It took microcontrollers a few decades to get caught up, but now, it seems just about every microcontroller developer has their own portfolio of devices that feature at least 2 cores. Under this model, the processing cores might operate independently or in concert. Many of these systems are asymmetric and have one processing core that is substantially more powerful or more specialized than its counterpart. This allows for purpose-driven pairings, where, for example, you might have one core performing very data-intensive tasks and the remaining core doing real-time operations. Secure microcontrollers seem to do this a lot, and I think the trend will only continue as demand for deterministic and intrinsically safe microcontrollers pushes these to greater heights. Number 10. Vision processing units. Autonomous vehicles and augmented reality rely very heavily on low-latency machine vision algorithms. The fastest systems use parallel computing architectures to perform functions like object detection, tracking, mapping, and image segmentation. But because of the sheer volume of data, many rely on the cloud, which increases their latency. Vision processing units, or VPUs, speed up the process, much like how graphics processing units currently do for personal computers. If I had to guess, I think VPUs are likely to dominate the premium smartphone market first, where some VPU product lines are already in their second generation. We have also seen vision accelerators that we can use to retrofit existing computers for faster vision processing, and they support popular frameworks such as TensorFlow Lite. And finally, only as an honorable mention, we have counter-drone technology. So this one did not make the top 10 because it is a niche application without a whole lot of broad consumer uses. However, this could change suddenly if we start to see air safety problems or simple congestion with drone traffic. In fact, I would say we already crossed the Rubicon because of drone-related debacles like airport infringements or near-miss events that make the news. Now, this is not an anti-drone argument. In fact, I'm trying to build one from scratch, but effective policymaking is going to distinguish between the large number of legitimate UAV use cases and the small number of bad actors who hope to cause harm. Besides the recent remote ID mandate, we've seen proposals to have commercial drones fitted with embedded geofencing to keep them out of restricted airspaces. Additionally, there have been proposals for standardized kill switch hardware that would let the authorities immobilize any drone they deem to be a threat. But let us know what you think, and if you found this useful, be sure to like and share the video. It helps me figure out what people are interested in, and it helps the channel in general. The monthly Patreon poll, which you can find a link to in the description, basically wants to know if you have any New Year's resolutions planned for 2021. Stay posted for more updates, and as always, have a great year.